Hey everybody, we're going to do a teardown video today of this Sharp PG-M10X. It's an old portable projector. It's a Sharp Notevision. This was pretty popular back around 2010, 2011. Very portable. You can connect it up to a computer or it has S-video and composite. Wow. So a couple of the screws are already out. I do need to take the lamp out. This projector is no good. It shuts down after it runs for a little bit. Might have a bad color wheel. Might have a bad fan. But either way, it's just an old projector, and I'm going to use it for parts. So first thing I'm going to do is take the BQC PG-M10 lamp out. That's the lamp. This is a Dlp projector, so this lamp actually has a UV-IR coating on the glass there. This particular lamp, going by the serial numbers, from 2011. So, still good, just not a popular lamp anymore. Bulb's still pretty useful. We'll save the door. These are handy. Sometimes people need them. Next, we're going to pop the front off. It already has the screws missing, so that just pops off. You just tilt it forward, and then just kind of wiggle like this. Come on, there we are. Just got to get these clips out. Now this wire is for the front IR, so I'll unplug that. It's a nice case. That's, oh yeah, magnesium right there. If anybody knows what this AZ91D means, let me know. I'm guessing it's a mold mark, but maybe it talks about the magnesium. I'm not sure. You can see how that switch works, or that latch. It's a very positive feeling latch. It's pretty nice. It's a shame this projector is not worth repairing. It just doesn't have a good good picture. It's just it's not high definition. It's not even 720. So then there's a mica shield over the ballast. This is the ballast right here. That takes 380 volts in on this side and then bumps it up to the high voltage and high current on the other side to drive the lamp. This is probably okay, so I plan on saving this. Let's take that screw out. There we go. Oh, the top's loose too. Alright, well, let's start with taking the top off. There we are. That just folds off. Looks like the speaker goes there. Tiny little speaker. 1 watt, 8 ohm. Again, more magnesium. That must mean something to do with magnesium. If I look that up and confirm that, I'll add something. Maybe down here, a little note. Alright, so the ballast unplugs, and then the control wires for the ballast also unplug, and then the M1 connector from the ballast. Alright, so this is an Osram Ballast. What's that say? Here we are. 370 volts in at almost 400 milliamps. That's pretty cool. And I think that might be the voltage range, 70 to 5,900 for the startup. I could be wrong though. I'm going to look this up too and see if I'm right about those specs. But power comes in here, gets filtered, goes through an inductor, and then there's some switching MOSFETs over here that pulse it through that high voltage transformer, which then boosts it to here. And then we have another choke, and then this is the control circuitry. This monitors the current through these guys, I believe, and can tell the projector if the lamp is running or not. That's what these are. There's two opto isolators there. One is for lamp turn on, it's an incoming signal, and then the other one's an outgoing TTL signal that tells it if the lamp's running or not. Other models of ballast will have three, and one of those is for setting the brightness level, if it's dim or not. So we'll set that off to the side because that's good. Next, let's get the, let's see, what's the next neat thing to look at? Let's take the optic assembly out. There's another one here. Then on the top side, or the left side if you're looking at it from the back. And there should be one more down that corner. There we are. Now we should be able to, yep. Alright, so that's loose with the color wheel, but it's not coming out because it means we have other things to disconnect. So let's see, let's unhook that cable. We don't need that anymore. Unhook this cable that ran to the front. So let's see, this is the, oh yeah. So that's for the infrared. That was for the ballast. And let's unplug the temperature sensor, which is right here. That is a, let's see if we can read that. 250 volt, 2 amp, 127 degrees C. So that should open at 127 C. It's actually kind of handy. I'll keep that. And we have a small blower fan. Where's that? That's color wheel sensor right here. And then another 2 wire, it's probably the lamp switch or the door switch. And then a fan, and another fan over on that side. That should be all those wires. So let's pop this main board out. Alright, main board's loose. There's a wire or something on this side, probably low voltage power supply. Yep, that's a big wire for a low voltage power supply. There we go. There's the main board. We'll do a quick tour. Alright, so we have a Pixelworks chip here. Video processing, obviously. We have ROM for the firmware to run the projector. SEC, I don't know what this chip does, but let's do a little tour of this board here. It's actually kind of interesting, the amount of stuff they crammed into it. We'll start at the input side, whether you use VGA or one of the composite or S-video inputs. Those are most likely going to feed into this chip right here, this SEC KSO127B. This is an NTSC PAL CCAM decoder. So just going by the distance, that would make sense. Then the VGA is likely feeding into this analog devices chip. This is a flat panel RGB interface. It's got a maximum resolution of 1280 by 1024 at 75 Hertz. So obviously it's not going to be a real big picture with today's video. And then this is some kind of ROM. I didn't peel the sticker up yet. Let's see if we can do this on camera. We can see what kind of RAM this is. There you go. It's a LH28F 400 BVE. And then, of course, we got the Pixelworks chip over here. It's a 50 megahertz Pixelworks chip. It's a BGA package. And that's doing the video formatting that's going out to the DMD board, which we'll look at next. Then on this side, we have digital to analog converter. I don't know what that is. Power supply, power supply. What's this guy? What's that say? I can't really tell what these little 8-pin packages are. This thing here, this ST72T631. This is an 8-bit microcontroller. There's its crystal. This is kind of cool. I might actually keep this and do something with it. And then just some more power stuff. We have these guys. These are 16-bit flip-flop chips. Must be doing something for the video. And then we have some buttons, and some LEDs, and some power stuff, and a bunch of passives. So that's the main board. This is never going back in. It's going to get scrapped down shortly. So I'm not worried about static. See? Touching everything. Next, we have the DLP and main video. Why isn't that coming out? What other screws do I have to take out? Ah, got one here. Always another screw. Normally I check the service manual to see what the order should be for disassembly. But sometimes, especially with scrap teardown, there's really no reason to take it apart in order. So I'm not going to. But I am trying to get this black bracket out. There's got to be a screw that I'm missing. Yep. Down. So I really want to lift these fans out. These are nice little fans. There we go. Interesting. Somebody was in there. It's all missing. That might be, ooh. I don't know if you guys can hear it. Sticking. That might be the magnet causing that. But you can tell this is an old fan. The fact that it's using a circlip to hold it together. Metal circlip. Alright, anyway. Now let's see if this mess lifts out. Or what else I have to disconnect. Oh, let's unplug the color wheel. There we go. So I just gotta give it some love. And then it'll lift out. Let's get that power wire out of the way. I'll move this over. So here's the optic assembly. There's the lens. There's the inside of the optic assembly. It's interesting because it doesn't have a cover. It just uses the bottom of the projector to seal all that in. So the light path actually should be pretty obvious here. I get my flashlight to help demonstrate, but my flashlight would be the lamp. I don't know if you guys, yeah, you can. So the light goes through here and shines through the color wheel. Now, in this case, the color wheel is on the clear. Let's take it to red, or green rather. So if the light shines through the green segment, you will have green light. Light path is kind of interesting. So if I can hold this one-handed and I can point it out. So the light goes through the color wheel, which is right here, through the integrator, which is right here, through some lenses to just tighten the beam up a little bit and get it shining properly. And Then it hits this mirror. Once it hits this mirror, it hits this mirror. Let's see if I can, there we go. Yeah, so you can see the green. Then once it shines off of that mirror, it shines directly onto the face of the DLP chip, which is right here. After it hits the DLP chip, it reflects to the main lens, which is right there. So it's kind of neat. So the light goes here, 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 and then out. You could possibly stretch all this out, but this is a nice compact way of doing it. So let's take this apart. Let's see the color wheel. Color wheel is probably the most common failure besides a lamp and a DLP projector. Man, these older projectors are neat to work on. There we go. So they're just built so cleverly back then. This is the color wheel index sensor. That's an infrared transmitter receiver that watches the color wheel hub. Here we are. For that reflective mark. That little reflective mark bounces the light back and tells the projector when the color wheel, I guess in this case, when the blue section, that must be the beginning of the color sequence, must be the blue section. That's how it synchronizes itself to have the proper color. Let's take this screw out. It's a really long screw. And let's take out this screw. And we should be able to lift the shroud off the color wheel. Let's see the color wheel. There we are. There's the shroud. And then there's the color wheel. Uses a little stepper motor to drive it. Usually these will have an index mark here instead of on the side of the hub. It's a nice color wheel though. You can keep it. Never know. Somebody might need one sometime and then I'll have it. So to take it out, we're just going to take these screws out. Get that one. This one. And this one. Let's see if I can pop this loose without breaking it. There we go. There was some, there's a heat sink pad right here it was sticking to. These do get warm from the lamps shining on them. This one's in good shape. I'm going to put that one away. Next, let's take out the integrator and lens assembly, which is this part right here. The integrator is the little light tunnel. Inside there, the 4 pieces of mirror that are facing each other to condense the light beam into a nice coherent beam. It's not quite a collimator, but it's similar in idea. That out. There we go. And there's the lens. You can see when I do that the reflection of the different mirrored segments in the integrator. Let's see if I can get a little closer. See, those are all, that's just 4 mirrors set up in a rectangle all facing in on each other. And they're adjustable. Sometimes this one, not sure how to adjust this one. Looks like it's just held in place. Adjustments must be done elsewhere. Sometimes you can adjust the angle, you know, that way or this way, depending. Like I said, I didn't look at the service manual on this one because we're just taking it apart. All right, next, let's get the Dlp chip off. First, let's get that heatsink out of the way. I haven't seen a heatsink like this in a while. It's just aluminum sheets with spacers. You know this costs a lot more to make than, you know, something like that. Or maybe not more to make, but it was definitely more to assemble. It's interesting seeing the construction methods change over the years. Now we're going to take these mounting screws off that hold the chip to the optic assembly. And we'll do a quick tour of the chips. Alright. So this is the DMD board. Let's get that Dlp chip out. They're using a zebra cable to connect it. Maybe there's a screw under here. It's just not pulling. There we go. I was just stuck. Alright, there's the Dlp chip. It's an older type. Let's see what the part number is. That's probably it. Yeah, it's not coming off. These were a lot of money back in the day. It's probably worth, I don't know, $5, if that, now. And then the zebra cables to connect it. What we see here are actually numerous wires. Each one of those little marks is a wire, and then it's just put together in a strip like this. It gets sandwiched. Oops. Like that, and then passes those through to this. So you can see the gray parts of the conductor and the pink is the insulator. Alright, so let's look at this board. Dlp DMD control chip right here. Some RAM. Another Dlp chip, control chip. An Atmel. XGA, interesting. I wonder if that's a microcontroller or if that's RAM. Not sure. Power stuff. There's probably an EEPROM in here somewhere. Nope, none of those. And we go to this side. More RAM. The main Dlp Blaze chip. Another Dlp controller. And then this is a motor driver for the color wheel. It's a stepper motor driver, and then just some power stuff. So not much to it. I'm going to look this chip up and make sure it's useful. If it is, I might save it. I don't see a crystal around it though, so I'm guessing it's some type of ROM. Well, if I look it up and it's different, I'll correct it here. Alright, so let's get the rest of this apart so we can see all the optics. So I got a couple screws to take out here. 1, 2, 3, 4 screws. And you can see these nice first surface mirrors. The mirrors inside projectors are just so nice. The quality of the coating is really good. Now, if I were going to be reusing this, I wouldn't be handling it this way. There's the mirror. Nice concave mirror. It's pretty cool. I'm going to save this. And then we got another mirror. Let's see, that's held in by these screws. Let's see, let's take those out and we'll let it fall into my hand. in this case is possibly also magnesium. I'm looking for, yep, there it is. Oops, MgAZ91D. That must be the type of magnesium. I need to familiarize myself with this stuff a little more. Metallurgy. And let's take the lens off. Once the lens is out, that other mirror should pop right out. There we go. It's probably the, oops, that's probably the part number. It's interesting. This projector doesn't have zoom. It only has focus. This is where it's screwed to the projector, and then when you turn that, you can see it's changing the spacing. Now, I suspect you might be able to tweak the zoom a little if we loosen this screw up. Just curious, I'm not sure, but we'll check. Let's see. Loosen those. No? Let's take this brass one all the way out, because I think that might be locking it. Unless that's just part of the handle. It kind of feels like it's just part of the handle. Oh, I see. Alright, so one of these has to come out, and this stays in. Alright, so this is a handle. So put that back in, and we'll just take one of these screws all the way out. Now, I should be able to, yep. And then you can still, yeah, so this is like a hard zoom, I guess. Let's pop that out and make sure, because I'm still wondering if that's really anything to do with zoom, because that ring comes off and that's it. Oh, you know what that is? That just keeps you from taking this out. Like that. Yeah, there's more screws in there. Oh yeah, so then that pops off. It literally just pops off. Take these out. Hoping it would then come apart. Nope. There's probably glue in it. See, there's a seam here I'm trying to get into. Oh well. Another time. Let's get this out. There's another first surface mirror. So we're going to keep those. And now we have an empty optic assembly housing made out of magnesium. Last thing, or last assembly to look at, screws out of the way, is the power supply, which I said earlier, which you can see, is a Sony power supply. It's not uncommon for other manufacturers to use parts from what you may consider a competitor to them. Competitor, there we go, I can speak. So these standoffs come out. They hold that in. Looks like there's another couple little screws. We got a ground. I really should use a bigger screwdriver, but I got it. And then we have another fan. And the lamp holder, the lamp well, lamp carrier, whatever you want to call it. Yeah, see, somebody was in here. That fan should not look like that. And then the holder with the temp sensor, which I'm going to unscrew right now because that's something I need this for. Alright, so the power supply is now loose. Slide it out of that. Let's take the plastic off. Put that away. There's the power supply. It's pretty modern. I mean, it's 2011? No, earlier than that, 2000 something, early 2000s. So this projector is probably 15 to 20 years old. I have not looked up the date on it, but just going by the lamp, I know it's an older one. The way this power supply works, we have line voltage coming in here, AC line voltage 110, that little fuse. Then we have a common mode choke, I think that's called. It suppresses RF noise. Then we have a bridge rectifier, big old bridge rectifier. Then we'll go to the bottom because it's easier to see the rest of it from here. Bridge rectifier, we have let's see, we have positive and negative. So the positive goes out into the system. Wait a minute, do I have this right? Yeah. And then we have some MOSFETs down in there, some control circuitry, big old 400 volt, 100 mic cap. That's part of the power factor control. It then uses power factor correction to boost the rectified AC up to 380 or so to power the ballast. Then there's another power supply. I believe this is a switching supply, and that's what these guys, these transistors or MOSFETs are for. Yeah, they're MOSFETs. They are 10 amp maybe. Go through this transformer, and then we have a whole bunch of Schottky diodes and regulators for the low voltage. Low voltage comes out here. You can see there's a lot of wires, but really only a couple voltages. Looks like we have ground, and then what do we have? 6.3 volts across that one. So this is probably 5 volt, probably 5, 12, 3.3, something like that. So low voltage, high voltage DC, high voltage AC. That's really all there is to it. It's a pretty straightforward basic projector. And here's all the parts set together. Just thought I'd make a fun little pile so you can see what's all in there. Front cover, top cover, lamp holder, lamp, ballast, 1 fan, 2 fan, vent, optical housing, lens, main board with stuff, DLP board with stuff, power supply with stuff, and last but not least, almost forgot, the door switch. So there you go. There's the inside of a Sharp DLP projector, model number PG-M10X. If you have any questions, you want to see any other teardowns, don't know, anything, leave a comment below. Hit the subscribe button. Hit the like or dislike button. Either way. And yeah, thanks for watching.